Okay, so now today we're gonna continue with example regarding the excess air. Okay, you might want to pause your video to read the question. Okay, you have a combustion chamber. Okay, the fuel is C3H8 with 0.05 kilogram per minute and with 50% excess air. Okay, the product of this combustion is, so you're gonna have carbon dioxide, H2O, and 2, and this one is actually carbon monoxide. Okay, so since the process, air is excess, 50% excess, so you're gonna have excess of O2. Okay, take a look at this product. CO2, H2O, and N2 is actually supposed to be the combustion, right? The product of combustion between C3H8 and air. CO is actually being stated by the equation, meaning there is a product of carbon monoxide. And when you have 50% excess air, you need to put O2 as your product. Okay, so that's how we determine the product for excess air. When you have an excess air as a part of a reactant. Okay, how we're gonna balance this problem for excess air? At first, what we need to do is we need to find the theoretical amount of air. Okay, so we need to, this is the balance equation in order for us to determine the theoretical amount of air plus ATH chemical composition of air plus X CO2 plus Y H2O plus 3.76 ATH into. Okay, notice here we left out at first. Okay, since we want to find the ATH, right, we left out the carbon monoxide and O2. Alright, so yeah, we need to balance this equation. Okay, let's start with carbon. So for C, so this is 3. So here is, this one is 3 and this one is X. So basically X is actually equals to 3. Next we balance for H2. Okay, I'm using H2. You can use H also, right? It's up to you. So I'm using H2. So meaning this one is 4, right? H8 become 4, and this one is equals to, same, this is also H2, so meaning y is actually equals to 4. Alright. Okay, next we balance for O2. So O2 at the left hand side is ATH. This one we have ATH equals to X, right? This part X. So X is now, we already know the value. So X is 3. And then Y is actually 4 divided by 2, right? So since Y equals to 4, here is O only, not O2. So meaning plus 2. Or I can put it as 4 divided by 2. And equals to 5. Okay. So next part, maybe you need to find this one. Right. So you can put it as Z. So Z is actually 3.76 ATH. Okay. Which is equals to 18.8. Okay. Alright. Why 3.76 ATH? Because if you balance for N here, N2, 3.76 multiplied with ATH, so meaning it's actually same, 3.76 ATH. So what we have here in this balance equation, we found the ATH, the theoretical amount of air for this problem, which is 5. Okay, so for 50% excess air, okay, so I can put it here as maybe 100%. Okay, 100%. 100% ATH. Okay, 100% ATH. So meaning this one is 150% excess. Okay, not excess air. 150% ATH. So meaning this is actually 1.5. And this one is, of course, ATH, right? Okay. Oh, okay. Alright. So how about we write back the equation for 100% theoretical, right? So we have C3H8 plus, now the ATH is 502 plus 3.76 and 2. So X is 3 CO2 plus, and then we have Y, which is 4H2O, and then here we have Z, which is 18.8 and N2. Okay, alright. Next we go for 150% ATH, which is 1.5 ATH, right? Okay, so next we write down the equation for 1.5 ATH. Okay, so you have C3H8 plus, okay, this one is air, right? So 1.5 multiplied with 5, okay, 1.5 ATH, O2 plus 3.76 and 2. Okay, next we go to the carbon dioxide, right, as a part of this one. Okay, if you notice, carbon dioxide from the equation is actually 90%, so 0.9 carbon dioxide. Okay, so from this one, carbon dioxide is 3 CO2 and multiply with 0.9, and then H2O, so it's not going to change as well. For H2O plus, they put it as a carbon monoxide. Okay, we have formation of carbon monoxide, CO. Okay, and then plus O2 due to excess air, and then nitrogen. Okay. So X, Y, and Z. So we need to find the value of X, Y, and Z. Okay, so we can start with carbon. So at the left hand side, okay, carbon is 3. So this one equals to this one. At the right hand side is 2.7. And here we have plus X. So from there, X is equals to 0.3, right? Okay, next we go for oxygen. Okay, I'm using O2. So here we have O2 1.5 multiplied with 5 is 7.5, right? And we have O2 as well here, so 2.7, right? And the left hand side is X is known, but this one is O, right? So sorry, we start with this one. Okay, O, so 4 plus 4. Okay, not O2, so meaning 4 divided by 2. This one is O only, so 0.3 is known. This is O, so 0.3 is known. So meaning 0.3 divided by 2, and then plus O2, which is Y, plus Y. So from there, Y is 2.65. Okay, next we go for nitrogen. So nitrogen is the left hand side. So right, so this is nitrogen. So 3.76, 1.5. Okay, 1.5. I mean, you can put it as 7.5. 1.5 multiplied with 5 and then multiply with 3.76. So that's all at the left hand side. At the right hand side is z, right? So therefore z is 28.2. Alright. Okay. So that's the balance equation for 150% ETH, meaning 50% excess. And okay, you can check this one because if you notice here, 10% forming carbon monoxide, right? 10% forming carbon monoxide. So you can check this value. Okay, so 0.3 divided by 3 is actually 0.1, so 10%. Okay, so even you can check with this one as well. This one is 2.7 divided by 3, and you're gonna get 0.9, which is 90%. See, 90% of carbon become carbon dioxide, 10% of carbon become, the fuel become carbon monoxide. Alright. So what left out is we just need to write down back all the balance equation. C3H8 7.5 O2 plus 3.76 N2, and this one equals to 2.7 CO2 plus 4H2O carbon monoxide is 0.3, and Y is 2.65 O2 plus N2 is 28.2. Okay, that's the final balance equation for 50% excess air. Okay, next question number 1, they ask you to calculate air to fuel ratio. So meaning air to fuel ratio is mass of air divided by mass of fuel. So number of moles multiplied with molar mass of air. Similarly, number of moles and then fuel. So here you have 7.5. So the number of mole is 7.5 multiplied with the number of mole of air 4.76 and multiplied with the molar mass 29. Okay, next calculating the fuel we use for so we have 3 kilomole, 3 for carbon, this one. Now so for carbon, 3 multiplied with 12, the number of the molar mass, and then now we solve for H. So we take H2. Okay, H2 is 4, so the molar mass is 2, right? So from there you're gonna get the value of air to fuel ratio is 25.53 kg air per kg fuel. Alright, and number 2, calculate the mass flow rate of air, m dot air. Okay, we're going to use the same equation, meaning the air to fuel ratio m dot air divided by m dot fuel. This one is mass air divided by mass fuel, but it's the same. Okay, mass flow rate of air divided by mass flow rate of fuel also produces air to fuel ratio. So from here, m dot air is AF multiplied with m dot fuel. Okay, so m dot fuel is given 0.05 kilogram per minute. So from there you're gonna get 1.18 kilogram air per minute. Okay, if they ask you for kilogram per second, so you just convert. So okay, so that's all. Thank you.